All right, welcome. Today we are diving deep into something that's both fascinating and honestly has incredibly high stakes. AI in medicine. You see, AI is getting so good it's almost superhuman at things like diagnosing medical conditions. But all that power comes with a pretty huge challenge, and it all boils down to one simple question. So picture this. An AI looks at a medical scan and spits out a diagnosis, and it's more accurate than any human doctor. I mean, that's a total game changer for healthcare, right? But what happens when the doctor, the person who's actually responsible for the patient, looks at that diagnosis and asks a very simple, very human question? Why?
And right there, that's where we slam into the wall of the black box. See, a lot of the most powerful AIs today, especially the ones built on deep learning, are black boxes. They take in data, like a scan, and they give you an answer, like a diagnosis. But the process in the middle, it's a complete mystery. It's this incredibly complex mathematical maze, and even the experts who built it can't tell you the exact path it took to get to one specific answer.
Now, these aren't just nerdy tech questions. They're fundamental questions about trust. The U.S. Defense Advanced Research Projects Agency, or DARPA, really nailed it with these questions. If you're a doctor and you're going to partner with an AI, you have to be able to ask these things. If we can't get answers, how can we possibly build the trust we need when actual lives are on the line?
So that's the core problem we're up against, the AI's black box. But you know, researchers, they're not just throwing up their hands and accepting this mystery. Which brings us to the solution. There's this whole movement dedicated to prying open that box, and it's called XAI. The whole goal here is to turn these mysterious black boxes into what you might call transparent glass boxes. A black box just gives you the answer, and that's it. But a glass box, it gives you the answer, and it shows its work. It lays out the reasoning, making the whole thing understandable to us humans.
And this isn't just a small tweak. It's a whole new philosophy for building artificial intelligence. We call it Explainable AI, or XAI for short. The big idea is to create AI systems that we can actually collaborate with, not just, use like a calculator.
So this is the official definition from DARPA's Big XAI program. And if you read it closely, you'll see it's about way more than just explaining one decision. It's about understanding the AI's logic, knowing its limits, what it's good at, what it's bad at, and even getting a feel for how it's going to act down the road. It's about building a real mental model of your AI partner. Okay, so this all sounds great in theory, but how does an AI actually explain itself? Well, it turns out there are some pretty clever ways to do it, and they mostly fall into two big buckets. When you get right down to it, all these XAI techniques are really about one of two things: showing or telling. The AI can either show you, visually, what it was looking at, or it can tell you what it was thinking, using things like plain text or examples. Let's start with the visual stuff, because this is just so cool. One of the most common methods is something called a saliency map. Just think of it like a heat map that gets laid right on top of the original image. The hotspots, usually colored red, are the exact pixels the AI paid the most attention to when it made its decision. For a doctor, this is amazing. They can instantly see if the AI is looking at a real tumor or if it's getting thrown off by, say, a smudge on the scan.
But, a heat map can't always tell you the whole story. And that's where the non-visual explanations come in. These methods use examples, or text, or even simple statistics to make the AI's logic crystal clear.
So these non-visual methods can show up in a few different ways. We're going to look at three main types: using cases as examples, using text, and using other supporting info.
Okay, this first one, a case-based method called a counterfactual, is seriously brilliant. So imagine the AI looks at a chest x-ray and says, pneumonia. Then it creates a second image, a counterfactual, with the tiniest possible change that would make it flip its diagnosis to healthy. It literally shows the doctor the exact feature that was the tipping point. It's this perfect what-if explanation.
Then there are textual explanations, which are basically trying to create a conversation. With something called visual question answering, or VQA, a doctor could literally just type a question in plain English, like, "Hey, why did you flag this as abnormal?" And the AI would write back a sentence explaining what it saw. It's like having a real dialogue with the machine.
And finally, we have auxiliary explanations, which can be as simple as a confidence score. So the AI doesn't just say pneumonia.
It says pneumonia, and I'm 95% confident. That one little number gives you so much crucial context. Is the AI dead sure, or is this a toss-up? It helps the doctor know exactly how much weight to give that prediction.
But, and you knew there was a but coming, right? Once we start opening up that black box, it reveals this really fundamental tension in AI. It's this constant tug of war between getting the most accurate answer and actually understanding how we got it.
This chart really spells it out. As a general rule, the AI models that have the absolute best performance, the most accurate ones, like these giant deep learning networks, they're also the hardest to explain. They're the deepest, darkest black boxes. And on the flip side, models that are super easy to understand, like a simple decision tree, well, they often just can't compete on pure accuracy.
So this forces us to ask a really tough question, especially in a field like medicine. And I want you to think about this. What would you choose? A 99% accurate black box that gives you zero explanation? Or a 95% accurate glass box that can justify every single one of its decisions? There is no easy answer here. And this is the exact debate happening in labs and hospitals around the world right now.
And that question, it's not just about which number is bigger. It leads us straight to the future of our relationship with AI, the future of trust itself.
Because at the end of the day, XAI isn't just about satisfying our curiosity. It's absolutely critical for building AI responsibly. Explainability is how we check for fairness, how we find hidden biases in the data. It's how developers actually improve the models by seeing why they fail. And by forcing the AI to justify itself, we build the transparency we need for the ultimate goal, a safe and effective partnership between humans and machines.
And that, right there, is the key takeaway. The whole point of explainable AI isn't just to build a better tool for doctors to use, it's to build an AI partner that they can finally truly trust. Thanks for joining us for this explainer.